Okay, pupes. I'm inspired to think about research again about the Pupil Project. So here we go. So I thought I would share with you. I have discovered some more of the nature of the sort of data we have. So remember I was showing you those graphs last time, and I was like, oh, we need to create a variable or whatever that compares the pupil size at the beginning and the pupil size at the end. I think I may have started to do that. And you can see here around line 500 and 14, we create this variable called integration. And that combines this cond variable, which is basically just information about what each trial was, like was it an angry face, a happy face, what trial number was it, etc. And then there's some information about the fixations, like of X and Y, where they were looking. And then there's like, should the trial be thrown out if there was less than 50% good eye data during it or whatever. And then I added this summary pupil variable. I think, Abby, we might have done this together a long time ago. So what I'm going to do now is look in my little folder and see what is in that, what this integration variable looks like. So what happens is you save that variable as the subject ID integration. The name of it will be like 474 integration. And when you open it, you have this nice little summary thing. So let's do that. So I'm going to go to Lauren Rudder. That's where it lives. In case I die, you guys can find it on my computer. Lauren Rudder on the desktop. That folder is where the pupil data live. Integration. Where is it? It lives under, okay, integrated performance and fixation data 3. Okay, or right there. Slash integration. Oh, okay, hi. Yeah. Okay, so look at all these. All these files are files that we've created that are quote unquote these integration files. Subject 474 is the one I just made, and look at that. So when I double click on it, on the file, it creates this variable. Watch this. If I hit clear, that kills the variable. Now I do this and I load the variable, and now we have this integration variable. Well, what's this integration variable? If I type it in, it will print out like what the variable is. So, oh my gosh, look at all these data. It's too many data to possibly look at in MATLAB. It's like 26 columns. So what I'm going to do is I'm going to say XLS write integration 474.xls. I'm going to create an Excel file, and it's going to be based on this integration variable. That's a good command to know. So now whatever folder I'm in, I'm creating this Excel file, and now I'll go to that folder. I think I was actually maybe more or less the right folder. Okay, no. Lauren Rudder. Integration, performance, and fixation data 3, and look at that, an Excel file. The only Excel file in the whole folder, and it's with subject 474. So I open that, and look at this, massive file. If only we knew what it all meant. So I just created a new row here so we can write down what it all means. Sub ID, that's a sub ID. This is meaningless. I think this is probably, maybe Abby, you wrote this down at some point. I think, what does it range from 49 to 52? I think it's like what emotion it is or something. But we'll figure that out later. This is probably the reaction time, like how long it took them to press the space bar. You see, these are pretty close to each other. These two columns. Well, that one they're not close together. They're 15 seconds off, but now they're a second off, 2 seconds off, a second off, 2 seconds off. I don't know what the difference is between those. But this is just some basic information about the trial and what, how long it took them to respond. I don't know what all these mean. But I'm pretty sure. Ugh. Oh, nice. Look at that. I bet you this is the pupil size at the beginning and the end of the trial, just like I was talking to you guys about last time. I think so for trial 1, this would be the pupil size at the beginning and the pupil size at the end. I don't know if that's true though. See, this is what science often is like you come up with some great ideas and then you're so busy that you forget what your ideas were and you have to go back and figure out what the heck you already did. Ah, this is life. Okay, so let's find what this. So what we have to do is find the sum pupe variable. Sum pupe. Not find next, find previous. Ah, oh, look at that. And it's exactly what I just said. It's going to take the pupil start size and the pupil final size. Now, easy, Elgato. While we're doing this, let's figure out what was the start size. How do we calculate that start size? So it's. I think it is. Indeed, this is the pupe start size. Lovely. Pupe end size. Lovely. So what we could do then is in Excel even, we could very simply say equals, the end size minus the start size, probably like divided by the start size, which would be y2. That's going to give us the percentage. So negative 9%, 9.8% is how much the eye shrunk. Okay, the pupil shrunk during this trial. Let's look at all. We're missing a lot, and I don't know why. I presume it's because we didn't get good pupil data or something. That's okay. 2% increase, 5% increase, 3% increase, 2% decrease, 3% increase. This is fun. Isn't this fun? Just who knows what the truth should be? Who knew that during a trial of emotion recognition, the eye tends to increase by. I don't know. Let's take an average. What do you think? I'm guessing the average is going to be like a 6% increase. Oh, no way. The shrinkages offset the increases, and so the average is actually 0. Huh. So the pupil is actually not getting bigger on average. I'm suspect of that. So I want to know exactly how we calculated those starts and ends, the start size and final size. So let's look for that. Control H. Pupe underscore start size. Find previous. Okay. So look at that. So it's taking the mean of frames 3 through 1000. And then it is taking, so that's for the start size. And for the end size, it's taking the mean of the last 15% of the trial, I believe. This is a lot of math that I believe means the last 15% of the trial. Let's, just to remind you, to remind you and to remind me, let's look back at these quote-unquote pupil graphs, because I don't know if I really believe that frames 3 through 1000 is kind of arbitrary. Is that really what we want? Where are the pupil figures? Pupil size, 474. All right. So we're basically taking from frame 300 to 1000. Oh, golly. 300 to 1000, the average. 300 to 1000. This one is so short. Why would we take all the way to 1000? See what I mean? Why would we take? This trial isn't even 1000 long. They didn't even get to 1000 because 1000 would be like 1200 is 10 seconds. So you should be able to recognize this thing before 10 seconds, I would think. Let's take a look at like our Excel sheet here, and just for this subject, let's look at the average reaction time. 13.7. So yeah, that's 13.7 is the average, but there's many trials, such as this one, 7.5, 9. There's many trials that are below 10, 6. So I don't think we should be taking, I mean, frame 1000 is how long is that in seconds? How long does it take to collect 1000 frames? 1 divided by 120 is 0.0083. 0.0083 times 1000, oh, it's going to be 8.3. Yeah, 8.3 seconds. I think that's too long. So let's just do maybe for like a second after that or something, like 420. That's 1 second, maybe 2 seconds, just to round it out. 420. What's 420 plus 120? That's 540. Okay, that'd be 2 seconds. Basically, taking 2 seconds of data after this little dip thing happens. We're starting at 300 because that's safely after this dip, and then we take 2 seconds of data and we compare that to whatever happens at the end. I don't know. I'm worried about the end because there's a lot of these wonky thingies at the end too. These artifacts. I think those are really messing with us too. We have to get rid of those artifacts. We have to remove these little things from the data. What this is probably they're looking down to see where the space bar is so they can press it. And so we're losing the lock on the eye, and it's giving us a value that the pupil is 20 or whatever, or it's 0 when it's not. So we need to filter out those points from the data set. Someone remind me in the meeting on Friday we have to do that. But where were we? Okay, so yeah, now I'm going to alter the program. We'll rerun it for just subject 474. Once it works for subject 474, it'll work for everybody. And let's see what happens if I essentially overwrite this Excel file. Remember we had these values 0.009. So I'm going to X this out. Don't save. Then I have to go home. So this video will be over in 1 second. In just a minute. Let's get to the carrot we're chasing here and look at what the data look like after we alter the what it means to be the beginning of the trial. Okay. Gotta go to this integration thing. Integration 474, slap it in. And if I just say the same thing I said before, XLS, right, create the Excel file, what it'll do is just write over it, and here it is, waka waka. The file was changed at 509, which it is right now. All right, so now what I'll do is redo my thing, equals this, minus this, divided by the beginning one. That's not good. Okay, that was the end. All right, so guess what? Now we're going to take the average thing. Let's see if... The reason I redid that is because I really didn't think the pupil should be not changing at all during the trial. But I don't know. The average now is 1% increase in size. Maybe that's just the truth. Or maybe it's just that this one person. Or maybe it's affected by the artifacts. So those are all things we have to figure out. We have to remove the artifacts, try this again, and try it on other people and just see what it is. I have no idea what we should expect. But maybe you guys have seen things in other papers. That's another thing to compare it to see if we're kind of doing this right. So I'm going to stop the video and upload it for you guys.